FastMCP 3 implements a provider-based component registry pattern, where LocalProvider serves as the default storage mechanism for decorator-registered tools and resources. This abstraction enables modular composition by allowing components to be defined once and shared across multiple server instances. We're about to examine how a standalone LocalProvider instance can be created to host reusable components, which are then attached to separate FastMCP servers during initialization. The code will demonstrate component registration through decorators and provider attachment to achieve cross-server functionality. From FastMCP, import FastMCP. From FastMCP server providers, import LocalProvider. Hash create a reusable provider. Shared tools equals LocalProvider. At shared tools tool. Def greet name, SDR. Return hello name. At shared tools, resource data / version. Def get version SDR. Return 100. Hash attached to multiple servers. Server 1 equals FastMCP server 1. Providers equals shared tools. Server 2, FastMCP server 2. Providers equals shared tools. This code demonstrates the provider pattern in FastMCP 3, specifically showing how to share components across multiple servers using a reusable LocalProvider. The pattern creates a standalone provider instance that can be attached to multiple FastMCP servers, allowing components to be defined once and reused across servers. The implementation creates a LocalProvider instance called shared tools, then registers a tool greet and a resource get version using the provider's decorators. This provider is then passed to two separate FastMCP server instances, Server 1 and Server 2, making the same components available on both servers. This approach is particularly useful for maintaining consistency across multiple servers or for building reusable component libraries. The key advantage of this pattern is component reuse without duplication. Instead of defining the same tools and resources on each server, they're defined once in the shared provider. However, this also means changes to the shared provider affect all attached servers, which could be problematic if servers need different versions of components. The pattern is best suited for utility components that are truly shared across servers, rather than server-specific functionality. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which is the main class for creating MCP servers. From FastMCP server providers, import LocalProvider. Imports the LocalProvider class from the FastMCP server providers module, which is the default provider for components defined directly in the server code. Shared tools equals LocalProvider. Creates a LocalProvider instance and assigns it to the variable shared tools. This provider will serve as a source for tools, resources, and prompts that are defined directly in the code, making them available to clients through the FastMCP server. The LocalProvider is the default provider type used for components registered via decorators like @MCP tool. @shared tools tool. Decorates the following function as a shared tool in the FastMCP framework, making it discoverable and callable by MCP clients. The decorator registers the function with the server's LocalProvider, using the function name as the tool name unless explicitly overridden with a name parameter. This specific line doesn't create or configure the tool itself. It only marks the subsequent function for registration when the server initializes. Def greet name, SDR. Defines a function named greet that takes a single parameter name of type SDR and returns a value of type SDR. The type hints indicate the function expects a string input and will produce a string output, though the actual implementation isn't shown in this segment.
Return fhello name.
Returns a formatted string that embeds the name variable into the greeting, hello name. This is a basic f-string interpolation that creates a personalized greeting message.
At shared tools, resource data //version.
Registers a resource named version in the shared tools provider, making it available via the MCP protocol under the path data //version. This decorator marks the following function or class as a resource that clients can access through the FastMCP server's resource discovery mechanism. The resource will be served from the default local provider unless another provider is specified.
Def-get-version SDR
defines a function named getVersion that takes no parameters and returns a string value. The function signature indicates it will return the version information as a string, though the actual implementation isn't shown in this segment.
Return 100.
Returns the string literal 100 as the output value.
Hash attached to multiple servers. Server 1 equals FastMCP server 1. Providers equals shared tools.
Creates a FastMCP server instance named server 1 that uses the shared tools provider for resource discovery. The server identifier, server 1, will appear in MCP protocol handshakes to help clients identify this server, while the shared tools provider supplies the available tools, resources, and prompts that clients can access.
Server 2, FastMCP server 2. Providers equals shared tools.
Creates a FastMCP server instance named server 2 that uses the shared tools provider as its component source. The server identifier, server 2, will appear in MCP protocol handshakes for client identification, while shared tools determines which tools, resources, and prompts this server exposes to connected clients. The provider pattern in FastMCP 3 enables modular composition by allowing components to be defined once and shared across multiple server instances. By creating a standalone, local provider instance, you can register tools and resources using decorators, then attach that provider to separate FastMCP servers during initialization. This approach ensures consistency across servers while avoiding code duplication. The key trade-off is that changes to the shared provider affect all attached servers, making it ideal for truly shared utility components rather than server-specific functionality. The pattern demonstrates how FastMCP's provider abstraction facilitates clean separation of concerns and reusable component libraries.
Shared providers clone tools across servers. Yet each server insists it invented them alone.